Hi, Algebra. In this video, I'm going to cover the key features of quadratic equations. We're only going to work through part of this lesson up through page 5, and then you're going to work on completing part of an assessment. So a quadratic equation, what makes it a quadratic equation is the highest exponent is a 2. So we have this quadratic equation, this general form, y equals ax squared plus bx plus c. And when you graph a quadratic equation, it is called a parabola. So it's a U-shaped curve called a parabola. So we're going to look at some specific, very important parts and ways to describe the parabola that you need to know. The first is called concavity. Concavity, and this determines if the parabola opens up or down. If the parabola opens up or down. So I'm going to just kind of flip back and forth between Mrs. Roan's key and typing some things. So looking here at her key, concavity, the way the parabola opens, up or down. So can you write this into your lesson, please? So if a, the number in front of the x squared, if that's a positive number, like 3x squared, 4x squared, 2x squared, just positive x squared, then we say the parabola is concave up and it opens up. What that means is that the vertex is a minimum, or the parabola has a minimum. And if that number a is negative, if it's less than 0, negative x squared, negative 2x squared, negative 3x squared, etc., then the parabola is concave down and it opens down, so it has a maximum. So please make sure you have that on your notes. We're going to move on to something called the axis of symmetry. And this is kind of what it sounds like. It is the axis, or the line, that if you draw in and you fold the parabola over that line, it's going to match up directly onto itself. It's going to map onto itself. It has a concrete formula that we're going to utilize. That formula is x equals negative b divided by 2a, or the opposite of b divided by 2a. I like to use that opposite of b divided by 2a. So here the graph is already done for us. I can see if I start at the origin and move to the left, 1, 2, 3, 4. This is the axis of symmetry. All our axis of symmetries that we're going to look at are x equals lines. They're vertical lines. So this is going to be x equals negative 4. The turning point or vertex, is going to be the highest or the lowest point on the parabola, depending on if the parabola is concave up or down. If the parabola is concave up, meaning it opens up, that lowest point is going to be the minimum. And if the parabola is concave down, then that highest point is going to be the maximum, that vertex. So here, this parabola is concave up, so I'm looking at the lowest point on the graph. That's my turning point, or my vertex. And I'm just going to get the coordinates to that, starting at the origin. I'm going to the left 4, and I'm going down 1, 2, 3, 4, 5, 6 squares. So my vertex for this parabola is negative 4, negative 6. X-intercepts is going to be where the parabola crosses the x-axis, or intersects the x-axis. So here I have 2 of them at x equals 0 and x equals negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So my x-intercepts here are negative 8, 0, and 0, 0. The y-intercept is where the graph crosses the y-axis, or the vertical axis. It's at the origin here. So that's just going to be 0, 0. And you'll notice this is the value of c. Whatever the value of c is, that's going to be your y-intercept. So let me give you a couple of examples for y-intercept. If I have y equals 2x squared plus 4x plus 11, then my y-intercept is 0, 11. It's that simple. I'm just going to look at that c value. That c value is the value without an x. We call it the constant. It will always be what it is. Let's do minus 7. And if this is the case, then my y-intercept is 0, negative 7. Literally just looking at that last value. That c value is going to be your y-intercept. So here, 11, negative 7, that's how I'm going to determine the y-intercept if I'm not given the graph. All right, let's move on to page 2. Given the following graphs of quadratic functions, determine the key features listed. All right, so let me go back to the blank copy here. Concavity is just, does it open up? Does it open down? That's what we're looking for. So, oops, what did I just do? There we go. Okay. This is fun. Okay. So this is concave up. It opens up. The axis of symmetry is going to be this line that I could draw on here that would split the parabola in half. So it's got to go through the turning point of the vertex. So it's going to be this vertical line here that I'm kind of tracing. And if I go from the origin, I'm moving to the left too. So my axis of symmetry is going to be x equals -2. X equals -2. Let me make this a little bit smaller. All right, vertex. What is it, and what is it, a min or a max? So the vertex or turning point is this point right here, this bottom point. It has the coordinates. I'm going to the left 1, 2, and down 3. So -2, -3. And it's a minimum because that is the lowest point on the parabola. The x-intercepts are going to be where the parabola intersects the x-axis. So I have two x-intercepts right here and right here. So this one is at 1, 0. And the other x-intercept is at the origin 1, 2, 3, 4, 5. So -5, 0. And the y-intercept is where the parabola intersects the y-axis. This doesn't look like it's an integer value, so it's 0. I'm not moving left or right, and then I'm moving down. It looks like about -1.5, approximately, for the y-intercept. Let's check out Mrs. Roan's key. Okay, concave up. It opens up. Axis of symmetry is that x equals -2, this green line here. You have then, let's see, your vertex is this red point that she put in at -2, -3. It's a minimum because the graph is concave up. X-intercepts, she highlighted in yellow, -5, 0, and +1, 0. And the y-intercept, okay, she rounded it to -2, 0, -2. I'm fine with that. It's hard to tell exactly what it is. So I'm okay with 0, -1.5, or 0, -2. Okay. So that was that question here. All right, on the next one, why don't you pause the video and work through this question number 2 on your own. It's asking the same exact things, and then I'll come back and go through it with you. All right, so here goes. Concavity, this parabola is opening down, so it's going to be concave down. The axis of symmetry is going to be the vertical line that cuts the parabola in half. So it has to go through the turning point of the vertex. So it looks like it's this line here, which is going to be 1 to the right of the origin. So x equals 1. The vertex is this point here. So if I start at the origin, I'm going to the right 1, up 3. The vertex is going to be 1, 3. And it's going to be a maximum because that's the highest point on the graph. The x-intercepts are -1, 0, and 1, 2, 3, 0. -1, 0, and 3, 0. And the y-intercept is 0, +2. 0, +2. So let's take a look at Mrs. Roan's key here. Concave down, talked about that. Axis symmetry, she put in green, x equals 1. The vertex should be 1, 3. That's just a mistake. That should be 1, 3 for the vertex. To the right 1, up 3. It is a maximum. The x-intercepts that she put in yellow, -1, 0, and 3, 0. And the y-intercept is 0, +2. 0, +2. All right, I'm going to pause the video here. That's about halfway through the lesson and make a video for the second part.